Okay. Now, one more question is there. Observe carefully and tell me how we got this equation. If water bounces back with the same speed, then force exerted on the wall is. First, water is coming and hitting. It will become twice. Why? Because in opposite direction also, force will be same. Isn't it?
Yes, sir.
That's why AV square D plus AV square D. How much it will be? AV square D plus AV square D. How much it will be?
2AV square D.
That's it. 2AV square D. So if water bounces back with the same speed, then the force exerted on the wall is how much? 2AV square D. If water is not bouncing with a speed, or if it comes to rest after hitting it, what will be the force? The force will be AV square D. So you have to remember these two values. But now tell me again.
Sir, AV square D.
AV square D is what? When we have to use this AV square D equation?
So when the water does not bounce back
When water does
after
not bounce
striking.
back. Okay. So water comes from some point and comes and hit the wall. And after that, if water is there, it is still, that means it is a rest position. Then the force exerted on the wall will be AV square D. Okay. Is it clear? Arnav, Bhumika, all
Yes,
others
sir.
tell me, is it clear or not? If it is not clear, I will explain in a shortest way also. Bhumika, Milan, Sahas, at least message me. You understood or not? Milan? Milan? Milan, Sahas, message me fast. You are listening to me or not? Milan, Sahas. Okay. Right. So AV square D and 2AV square D, you have to remember these two equations. Okay. Now, let us see one more slide here. If water rebounces with a velocity V1 instead of V, then the force exerted on the wall is. Now first, suppose one pipe is there. From the pipe, water is coming like this and it is hitting the wall. And when it is hitting the wall, first the force exerted is how much? A V square D. But if in opposite direction, fluid is moving with a velocity V1 square, then what we have to write? A V1 square D. Then what will be the total force? Total force F is equal to F1 plus F2. So in this F1 and F2, AD V, sorry. Okay, so F1 is equal to AV square D. And in case of other force, what will come actually? That equation will be there like this. Sorry, F2 equation I have to change. So I'll write here again. So F2 will be A V D into V1 will come, as velocity is changing when rebouncing it. So A V D V1 will be there. So now if F1 and F2 are added, so F is equal to F1 plus F2. So then we have to write like this, AVD will be remaining constant, and in a first one V will be there, and in a second one V1 will be there. So this one will be the equation for a net force. So don't consider this equation. So consider this equation. See here, again, for a first force equation will be AV square D. For a second equation, what will be the equation? AVD, and when it is rebouncing back, V1 we have to take. In earlier case, as liquid is bouncing back with the same velocity, we are writing V here. So V into V, V square it will become. So that's why we wrote 2A V square D. But here, as it is rebouncing with a velocity V1, the value will change. So that value will be there like this. And you have to remember these equations. If you remember this equation, if any numerical comes related to this particular equation, you have to solve. So again, observe carefully. If water rebounds with velocity V1, not with the same speed, then the force exerted on the wall, you have to write like this: AdV into V plus V1. Whereas A is the area of cross section, D is the density of the liquid, V is the velocity before striking, V1 is the velocity after striking it. Okay, Arnav, is it
Yes,
clear?
sir. Yes, sir.
Okay, if water strikes the surface at an angle theta, actually it is not Q there, it is theta. If water strikes surface at an angle, sorry, here whatever is there, this must be there like this, sorry, this must be there like this, which is called theta, that is angle. So if water strikes the surface at an angle theta with a normal and reflects with the same speed at the same angle, then the force exerted on the wall is how much? 2dAV square cos theta. Why cos theta term came? So let us try to understand that by some explanation like this. Now this is wall and water is coming like this, and normal for this wall will be there like this, and this water flow is making some angle with this particular normal theta, and with the same angle it is reflecting here theta. So the change of, sorry, the force exerted on the wall is how much we are giving? 2dAV square cos theta. So why we are giving it? Means actually force is a vector. Do you know?
Yes,
Do you know
sir.
force is a vector?
Yes, sir.
Vector means what?
Direction plus magnitude.
Direction, magnitude, whatever is there, that physical quantity will be called vector. Very good. Now when vector is there, that vector can be resoluted into two components. Whether vector chapter was explained to you or no?
So vectors is a chapter.
One chapter will be there, vector chapter will be there in physics. So whether it is there for you,
Sir, I think it's in 10th or 11th.
it will be there in the 11th also. But for you,
So
as
not
you
right
are in
now.
IIT Foundation, it is not there. Huh? Okay, if it is not there, you have to remember directly. Why? Because if you understand vectors, then only you can understand this equation. Okay. But in a simple words, I will say and try to understand. Okay. Or
Okay,
now,
sir.
now water is coming like this and hitting here. And when it is hitting here, for some force will be applied, and that force will be vector. And when it is a vector, it can be resoluted into two components. One is called vertical component and other is called horizontal component. And when water is leaving here, then also what happens? Some force will be acting here, and that force again will be resoluted into two components. One is vertical component and another is horizontal component. So observe carefully. horizontal component of force is in a same direction for two cases, before striking and after striking. But vertical component, observe carefully, this is in upward direction, whereas this is in downward direction. So these two will be cancelled with each other. So this vertical component will not play important role and only horizontal component will play. And whenever horizontal component is there, you have to write cos theta. Do you know about cos theta? Cos angle? Whether that is there in your mathematics? Cos theta, sin theta, cosec theta, tan theta, like that? Or no?
Sir, it's not in maths, but our physics sir told about cos.
Okay, right. What is cos according to you? Cos theta.
Sir, he gave the value like cos 0 degree
Okay,
is
okay,
1, cos
okay,
180 is minus 1.
okay. Right. And generally, this cos theta, sec theta, cosec theta, all will be defined in one triangle, which is called right angular triangle. And in a right angular triangle, one angle will be 90 degrees and other angle will be there like this. And let us take this as theta. And for this theta, if you write cos value, then you have to find out one ratio, Nana, and that ratio will be called adjacent side by hypotenuse. Which side? Adjacent side for the theta. Now this for theta, this will become adjacent side and this value you have to substitute and this will become hypotenuse. So if you substitute adjacent side value and hypotenuse value, then whatever the value you get, that will be called cos theta. Okay. And for a sin theta, one value will be there and that sin theta will be called opposite side by hypotenuse. So this will become opposite side then, and this is hypotenuse. So sin theta is equal to opposite side by hypotenuse. So that is about sin theta. So like that, sin theta and cos theta will be there. And generally, whenever horizontal component comes in physics, you have to write cos theta. Whenever vertical component comes like this, you have to write sin theta. So remember these two. Okay. Okay. Arnav.
Yes, sir.
For horizontal component, cos theta. For vertical component, what we have to write? Sin
Sine.
theta. Okay. Now here, just now I said, here these two vertical components will be cancelled with each other and the value will remain 0. And only which value will be there? Horizontal component value will be there. Why horizontal component value will be there? As both are in a same direction. So that's why as both are in a same direction, and that too in a horizontal case, that's why we are writing cos theta, and that term only is there in your, that term only there in your equation. So F is equal to 2dAV square cos theta. That will be force exerted by the liquid when it comes from the pipe and hits the wall with some angle theta and bounces in the same direction. Okay. And now calculation of force in different case. One more is also given. A metallic plate of mass M is kept held in midair, firing n bullets per second, each of mass M from below with the speed u. If the bullets rebound with the same speed after striking the plate, then the rate of change of momentum of bullets will be equal to weight of the plate. So this you have to derive, and this also needs some particular equations like vectors. So that's why I write directly here, rate of change of momentum of bullets. And generally tell me, what do you mean by momentum, Arnav?
Mass into velocity.
Very good, mass into velocity. And what is the mass of each bullet? Not given.
Not given, sir.
Given, no?
M.
Small m is given.
Yes, sir.
Okay. And the next one, it is going with a velocity u, isn't it? It is moving with a velocity u or not?
Yes, sir.
So momentum means how much? mu. But how many bullets are coming in each second?
N number of bullets.
So n number of bullets. So that's why I'm writing mun. So before before firing, momentum will be mun, and after rebounding, minus mun. And if you find out the change in momentum, then what you have to write? Mu minus mun, that means minus 2 mnu. But here, as we are not considering about direction, so that's why we wrote with the positive sign here. So 2 mnu. And this will be equal to what? Weight of the plate. So weight of the plate is how much? Mass into acceleration due to gravity. So that's why we are writing mg. So when a metallic plate of mass capital M was fired by a bullet with a speed u, and if it that bullet rebounds back with the same velocity, then the rate of change of momentum of the bullets will be equal to which one? Weight of the plate. So you have to derive equation, but that is somewhat vector related. So that's why you have to remember this equation. Okay. And next one, the force needed to stop a moving body with a speed u in a distance s will be given by mu square by 2s. How f is equal to mu square by 2s? How it will be mu square by 2s? Do you know?
No, sir.
Okay. Do you know about the equations of motion? Anyone? Equations of motion.
Yes, sir.
Tell me one equation of motion.
V equals to U plus AT.
Very good.
S
Very good.
equals to UT plus half AT square.
Very good. Very good.
V square is equals to U square plus 2S.
Very good. V square is equal to u square plus 2s. Three equations will be there. Those will be called equations of motion. Very nice. Keep it up. So in that one equation is there, v square minus u square is equal to 2s. So let me write that equation here. V square minus u square is equal to 2as. And here, observe carefully. First object is coming with the initial speed of u and it is stopping. That means initial velocity is u, final velocity is 0. Isn't it? Okay. Now, from this what I can write? A is equal to v square minus u square by 2s I can write. So which equal to v square means 0 square minus u square means u square by 2s. So acceleration A is equal to minus u square by 2s, and you know that F is equal to equation ma. So A means what I have to write? U square by 2s. So what this negative sign will tell, Arnav?
Deceleration or
Negative
negative
sign, what it will tell
acceleration.
us?
The negative acceleration.
Ah, very good. It is negative acceleration. Negative acceleration means in a opposite direction. But here we are not considering about direction. We are considering only about force. So that's why the equation will be what? F is equal to mu square by 2s. So this equation is given there. The force needed to stop a body moving with a speed u in a distance s will be given by which equation? F is equal to mu square by 2s, and as you are stopping it, you are applying force in opposite direction to the motion or not? You are applying the force in opposite direction or not to stop it.
Yes, sir.
So that's why negative sign will be there. But the magnitude, how much will be there? Mu square by 2s. That only given in that particular equation. And now, according to this equation, suppose I took two objects. Now let me draw here. Two objects are there, one object and other object. Now this object is coming and we are stopping it. This also coming with some speed and we are stopping at the same distance. Suppose it has to travel a distance of s. This also have to travel a distance of s. But initial speeds are different. Then the distance traveled by the objects generally will be proportional to what? Initial velocity. So that's why we write s is proportional to u square. So the distance traveled by an object will be proportional to u square here. So stopping distance you can say will be proportional to initial velocity. From this
So
equation
can
only
you
we
tell
can write.
once again?
Okay, Nana. Here f is equal to what is the equation?
So the stopping distance.
Tell me, suppose one object is there. It is coming with some velocity u and we are stopping it after traveling distance of s. Then how much opposite force we have to apply? How much force you have to apply?
So mu square upon 2s.
Very good. F is equal to mu square upon 2s. That you have to apply. Why you have to apply that much? Because we calculated F is equal to ma equation, based on that only we got it, isn't it?
Yes,
Arnav.
sir.
Okay. Now tell me in this equation what is u?
Initial velocity.
Very good. What is s?
Distance.
Which distance? The distance
Distance
traveled
into.
by an object before coming to rest,
Yes, sir.
isn't it?
Yes,
Isn't it?
sir.
Okay. So that means now suppose if same force I applied on two objects, same force I applied on two objects, but both are moving with a different speed. Understand carefully, Arnav. This is particular condition and which you have to understand. And if I give few problems, you have to solve them based on this. Okay.
Okay, sir.
We applied same force. Mass of objects is same, but both are moving with a different speeds. One is moving with a speed of 10 meter per second, other is moving with a 20 meter per second. And to stop them, I applied same force. Which one will travel more distance before it stops? Whether 20 meter per second object or 10 meter per second object?
20 meter per second.
Very good. Why?
Sir, because 10 meter per second will come to rest at faster time than 20
Very good.
meter per.
Okay, okay. So here, when velocity is more, it can travel more distance. Initial velocity, if it is more, it can travel more distance. So that's why the stopping distance for same case means if same force is applied on the two objects which are having same mass but with a different speeds, then the stopping distance will be proportional to what? U square. That point you have to remember. Sometimes directly you can use this equation and solve the problem easily. Okay. Same force must be there, same mass object must be there, but they must travel with a different speeds. Then only we have to use this particular point. What is that point? Stopping distance for the objects will be proportional to square of the initial distance. Is it clear?
Yes, sir.
Okay. Now next one. The force needed to stop a body of mass traveling with a speed of u in a time t. In a time t seconds is what? Mu by t. So how we got this equation again? Now see here. F is equal to what is the equation? Mv minus mu by t. So F is equal to mv means final velocity. No, v means final velocity or not?
Yes, sir.
Okay. Now here observe carefully. The force needed to stop it. That means final velocity will be 0. And when final velocity is 0, final momentum also will be 0. So 0 minus mu by t. So therefore F is equal to minus mu by t. Minus will say we are applying force in opposite direction, but the magnitude will be how much? Mu by t. So this is the equation. The force needed to stop a body of mass m traveling with a speed of u in a time t second is given by which equation? Mu by t. So in a different conditions, how the equation will be for a force that we are checking. Okay. Now, change of momentum in different cases generally. How we write?
So can we
Del
do this in the next class as time is
time not finished, no?
2 minutes left? So sir, new topics, a new day, new mind.
Okay, okay. So have you understood still now?
Yes, sir.
Okay. So you have to remember all this. Calculation of force in different cases. When water comes and hit the wall, but if that is there at a state of rest, then force exerted will be AV square D. If water comes with the same speed in opposite direction, then the force will be 2AV square D. And if water comes with a different velocity after hitting it, then the force will be, you have to write like this, AdV into V plus V1. V1 is the velocity after bouncing back. Next, if water comes with an angle theta, hitting the wall and moving with a same angle, then the force exerted is 2 dAv square cos theta. So you have to remember all these equations and we'll continue in a next class. And projectile also you are going to learn, and that projectile if you learn, this will be finished. But before that you have to solve these 4 problems, and in the next class first we will solve this problem, and after that I will say about this projectile motion. Is it clear?
Okay, sir.
Can you please explain mu by t equation once again, Bhumika? Okay. So I will explain that and we'll finish. Okay. Arnav, 1 minute only.
Okay, sir.
Right. The force needed to stop a body of mass m traveling with a speed u in a time t seconds is given by mu by t. So how we got it? F is equal to, you know that rate of change of momentum. That means final momentum minus initial momentum by time. So that I wrote like F is equal to, F is equal to final momentum mv minus initial momentum mu by time t. So final momentum is 0. Why final momentum is 0? Because we are stopping the body. When we are stopping the body, velocity, final velocity will be 0. If v is 0, mv also will be 0. So that's why I wrote 0 minus mu. Initially the speed is not 0. So u will be there. That's why we wrote mu by time that travel for a time t. So t we wrote. So therefore F is equal to 0 minus mu by t. So that is minus mu by t. And magnitude, if you take mu by t, we have to write. And what negative sign will tell us? Negative sign will tell us that opposite to the motion of that object you have to apply force. That's it. Is it clear, Bhumika? Bhumika, is it clear? Right. So let us finish session today.